Write and balance the chemical equation for the reaction. Carbon monoxide, CO, reacts with oxygen gas, O2, to produce carbon dioxide, CO2. The balanced chemical equation is 2CO plus O2 gives 2CO2. This stoichiometry tells us that 2 molecules of Ca react with exactly 1 molecule of O2 to produce 2 molecules of Ca2. Count the initial reactant molecules in the starting container, using the key provided, where gray circles represent C and white circles represent O. CO molecules, 1 gray circle bonded to 1 white circle, count them systematically to find there are exactly 6 CO molecules. O2 molecules, 2 bonded white circles, count them systematically to find there are exactly 4 O2 molecules. Identify the limiting reactant. Determine how much O2 is needed to react completely with all 6 molecules of Ca. 6 molecules of Ca times 1 molecule of O2 over 2 molecules of Ca equals 3 molecules of O2 needed, because we have 4 molecules of O2 initially and only need 3. CO is the limiting reactant. It will be completely consumed. O2 is the excess reactant. Calculate the contents of the container after the reaction goes to completion. CO remaining. Since it is the limiting reactant, 6 minus 6 is equal to 0 molecules remain. CO2 produced. Since CO and CO2 have a 1-to-1 stoichiometric ratio, 2-to-2, completely consuming 6 molecules of Ca produces exactly 6 molecules of Ca2, each represented by 1 central gray circle bonded to 2 white circles. O2 remaining. Out of the initial 4 molecules, 3 are consumed, leaving, for initial, 3 consumed equals 1 molecule of O2 remaining. Select the corresponding box. The final container must contain exactly 6 CO2 molecules and 1 unreacted O2 molecule. Looking at the choices, box B matches this composition perfectly, making option B the correct answer. The correct answer is option B, box B.